Right, today we're talking about composition of functions. And to explain what this is, I like to tell a story about my mother-in-law. My mother-in-law is a pediatrician, which is super handy to have on hand when you got small children. And occasionally I would call her and say, "Hey mom, how much Motrin can I give her?" And she would say, "Well, how much does she weigh?" And I'd say, "Well, about 30 pounds." And then I'd hear her kind of mumbling to herself, "Well, 30 pounds is kilograms and milligrams." And then she'd tell me how much Motrin I was supposed to give my daughter. So all the formulas my mother-in-law had learned for how many milligrams of Motrin you give a child were all based on how many kilograms the child weighs, not pounds. So she had to convert the number of pounds I told her into kilograms and then use her formula to get to milligrams. So she kind of used two functions in a row. So she took the pounds and plugged that into her conversion to kilograms. And then she took the kilograms and plugged that into her Motrin function, and that function would tell her how many milligrams. Another way to think about this, she first applied the kilogram formula. So she took, like, my daughter's 30 pounds and plugged it into her kilogram formula. And then she took that answer, that whole thing, and plugged it into her Motrin function. So the kilogram function notation is completely enclosed inside the parentheses for the Motrin function. So this is not multiplication of functions, it's taking one function and plugging it into another function. And that is what we call composing two functions, or finding the composition of two functions. So let's write down the definition of this. The composition of two functions f and g, and we can also call that f composed with g. This is just where we take f of g of x. Okay, so whatever function you say second is the one that's inside. The first one that you say has the big set of parentheses. All right, and so just like adding, subtracting, multiplying, and dividing all have a symbol that represents that, the symbol for composition is a little circle. So when you write this down with f and g, it kind of looks like the word fog. Okay, so we'll call this the f composed with g of x function. So let's actually find the composition of a couple of different functions. All right, so copy down our definition of composition of two functions in blue there. And they've asked us to find both f composed with g and g composed with f for these two functions, f of x and g of x. And it's important to note that f composed with g and g composed with f are not the same thing. It's kind of like subtraction and division. It matters what order you do it in. Okay, so let's start off with f composed with g. And the first thing we're going to do is just decode that notation. So this again means f of g of x. All right, and with compositions, you always, always, always start on the inside and work your way outside. So we're going to start off inside that set of parentheses with g of x. So remember, g of x is equal to x plus 5. So I'm just going to plug x plus 5 in for g of x. I'm just replacing g of x with its formula. Okay, so this is f with its big set of parentheses is still there. Inside is g of x, and I'm putting the formula for g of x. Okay, and then what I have here is like a problem back from section 1.1, where we're just asked to find f of something, right? So we're going to go up to the formula for f of x. F of x is x squared minus 3x, so I'm going to pull out all the x's. X squared minus 3 times x. So I've removed all of the x's from f of x, and I'm going to replace it with whatever's in the parentheses, which is x plus 5. All right, and this one's got a fair amount of simplification that needs to go on. So that x plus 5 squared, we need to multiply that out using either whatever box method or FOIL that you learned in high school. I'm going to use FOIL. X plus 5 squared is x plus 5 times x plus 5. And then we're also going to distribute that 3, the negative 3, to the x plus 5. So I'm going to have negative 3x minus 15. And then let's just multiply out x plus 5 times x plus 5. We're going to have our first terms give me x squared. Our outer terms give me 5x, inner 5x, and last 25. And then the 3x minus 15 is just hanging out. So I'm going to copy that down, minus 3x minus 15. And then all I have to do is gather up my like terms and we'll be done. So x squared, how many x's do I have? I got 5 plus 5 minus 3, that gives me 7. And then 25 minus 15 gives me 10. And there's our composition function. All right, so now let's try to find g composed with f. Okay, with g composed with f, they've swapped the order of the f and the g, so we're just going to swap the order of f and g in the definition of the composition. So instead of f of x having the big parentheses on the outside, g of x is going to get the big parentheses. So we're going to have g of f of x. Okay, so now f of x is the little function on the inside, and we're going to start on the inside. So f of x, I'm just going to replace that with its formula, which is x squared minus 3x. All right, so in the next line, I've got g of, and I'm going to replace f of x with its formula. And again, this is back in section 1.1, where we're just going up to the formula for g of x. G of x is x plus 5, so I'm going to pull out the x plus 5, and I'm going to replace the x with whatever's in the parentheses. All right, and I don't even really need that set of parentheses. There's nothing to simplify here. I'm just going to recopy this without the parentheses. And that's our answer. So that one was much easier to simplify than the first one. Let's try another one. So this one just wants us to find f composed with g for these two rational functions, 1 over x minus 2 and 5 over x. So again, let's just remember what that definition of f composed with g is. F is our outside function, g is our inside function. We're going to start on the inside and replace g of x with its formula. G of x is 5 over x. So this is going to be f of 5 over x. That means I go up to the formula for f of x and recopy it. Everywhere there's an x, I'm going to replace it with a window. And I'm going to fill those parentheses with 5 over x. And again, that set of parentheses you don't really need, so let's copy this without the parentheses. All right, and that beast is what we call a complex fraction. It's a fraction within a fraction, and you never want to leave an answer that way. So we need to do some simplification here. Let's look at the denominator there and get a common denominator within the denominator. So right now the 2 is really 2 over 1. So I'm going to multiply that by x over x, and that's going to give me a common denominator down there on the bottom. So up top I have 1 big fraction bar, 5 over x minus 2x over x. And that allows me to do some fraction subtraction. So I get 5 minus 2x and then x. And just be careful that that top bar is bigger than the bottom one, so you remember what's in the denominator there. And then we're really just dividing fractions here. So whether you learned keep, change, flip, or flip the second and multiply, or some form like that, we're going to leave the 1 alone. We're going to multiply, and we're going to flip that bottom fraction over. Okay, and 1 times anything is just the anything. And we get this function. All right, so that's finding formulas for compositions. Let's go take a look and see what this would look like with graphs of functions. So here we're given 2 graphs, one of f of x and one of g of x, and they ask us to evaluate some compositions using the graphs. So the first thing I'm going to do is to go down and get rid of the fog notation. So let's just write down what f composed with g of 5 would be. So there's a 5 in the place of the x. This is just going to be f of g of 5. And just like when we were finding formulas, when you're doing these from the graph, you're going to start on the inside and work your way out. So on the inside, I've got a g of 5. I'm going to go over to the graph of g of x, and here's 5. And let's see, that y coordinate is a 4. Okay, so this means that they want me to find f of 4. So I'm going to go over to the graph of f of x, and at 4, f of x is sitting there on the x-axis. It's got a 0 y coordinate. So f of 4 is equal to 0. So let's try part B. So I'm going to rewrite this g of f of 6. Okay, so whatever function is second gets to be the inside function, which is where we start, f of 6. So I'm going to go over to f of 6 on the left here, f of 6. There's a y coordinate of 2. So this is asking me to find g of 2. So I go over to g of x, and at 2, that looks like it's about 2.5. Let's say 2.5, 2.5. All right, so let's stick with these graphs and do a couple more. All right, next one is g composed with f of 1. So we'll rewrite that g of f of 1. Work our way inside out. Starting on the inside, f of 1, I go over to the graph of f of x. At 1, f of x is -1. My y coordinate's -1. So this is asking me to find g of -1. So I go over to the graph of g of x at x equals -1. We're at that sort of end point of the graph. It's a y coordinate of 3. So our answer is 3. So our last one is f composed with f of 5. It's possible that you can compose a function with itself, and this is exactly what's going on here. So this would just be f of 5. So f is both the inside and the outside function. You still start on the inside and work your way out. So f of 5, I'm going to go over to the graph of f. F of 5 is equal to 1. So this notation is asking me to find f of 1. So now I go over to f of 1, which we just found was equal to -1. All right, that's it for compositions of functions, and I'll see you in class.